Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. The subject is Maths and Calculus. The topic is today we are going to discuss on Maxima and Minima problems. Maxima and Minima problems. Before going to discuss here, we need to discuss the little bit the concept of the partial derivatives. In previous sessions, we discussed clearly about the partial derivatives under the two variables, the first order and second order. And today, based upon the partial derivatives, first and second order, we need to discuss that how to find the maxima and minima of the given functions with known and also unknown variables, like known and unknown constants. First of all, what is the partial derivatives? That means under the partial derivatives, again we need to recall the first order and second order. Whenever the given function is under the two variables, that is the independent variables x, y, based upon the function here, if we derivative with respect to x as a partially, that means we obtain that is dou a by dou x. That is the first order partial derivative with respect to x. And similarly, when we derivative with respect to y as a partially, that is dou a by dou y. This is also the first order partial derivative with respect to y. These are the two different types of the first order partial derivative with respect to x and y. And further, we need to find out the second order partial derivative with respect to x and y. Here, whatever the function dou a by dou x, that is a partial derivative, when we derivative with respect to x one more, that is dou square a by, that is dou x square. This is the second order partial derivative with respect to x. And similarly, whatever the dou a by dou x, we derivative with respect to y as a partially, we obtain the dou square a by dou y dou x. That means it is also second order partial derivative with respect to y and x. And further, whatever we completed, that is dou a by dou y, we need to further with respect to dou by dou x. That means dou square a by, that is dou y dou x or dou x dou y. And this is also the partial derivative with respect to second order under that x, y. And further, finally, whatever the dou a by dou y, again we need to derivative with respect to y as a partially, we obtain that dou square a by dou y square. Therefore, these are the three different type of the second order partial derivative with respect to x and y. The first order derivative with respect to x and y, only these are the two different types. That means the conclusion here, the dou square a by dou x dou y and dou square a by dou y dou x, these are the continuous functions whenever the function is continuous. That means whenever the function is continuous, it is always the satisfied dou square a by dou x dou y is equal to dou square a by dou y dou x. That means finally we need to remember here the dou a by dou x is the first order, dou a by dou y is also first order. And further, the dou square a by dou x square is the second order, and dou square a by dou x dou y and dou square a by dou y dou x both are same, that is also second order. And last one, it is a dou square a by dou y square. That means the first order derivative, it is sometimes denoted p, and it is a first order derivative with respect to y, that is a q. And whereas it is a second order derivative with respect to x, it is nothing but small r. And again, that dou square a by dou x dou y is equal to dou square a by dou y dou x, it is nothing but s. And further, dou square a by dou y square, it is meaning of this is the t terminology. Based upon this p comma q and again r s t, then we need to find out that is a maxima and minima of the given function under the two variables, that is x comma y, and sometimes under the three variables x comma y comma z, and based upon the with constants and without constants. And again we need to recall that totally the preview of the, that is a partial derivatives, that is a first and second order. That means again we need to recall these are the clear view of the first order and second order. Just now what we discussed under the first order briefly, and again the second order, it is according to p, q, r, s, t is a value. It is a p, and again it is a q, and again it is a r, and it is a s, and it is a t terminology. Sometimes in presence of R is nothing but it is L, and again S is nothing but M, and T is nothing but it is a N is a condition. These are the mainly we need to understand under the partial derivatives before going to discuss the maxima and minima of the given functions, like under the x comma y two variables and also based upon the three variables, that is x comma y comma z. And again, now we need to go to discuss that briefly about that how to find the maxima and minima of the given functions. And once again, before going to discuss the maxima and minima, we need to recall or remember some of the basic few points. That is about the what is the meaning of the extreme value, what is the meaning of the stationary or turning value, what is the meaning of the saddle point. And based upon these are the three different terminology, we need to discuss that briefly about the maxima and minima of the functions. And first of all, the extreme values. Regarding the extreme values, the extreme values are nothing but whenever the given function is to finding the maxima or minima, values are also known as a extreme values. That means a function is said to be maxima or minima values of the given function is called, that is the extreme values. And further, we need to understand what is the stationary, and sometimes it is also called as a turning values or turning points. The meaning of stationary or turning values is nothing but based upon that whatever we know that the first order with respect to x and y, that is dou f by dou x and dou f by dou y, we need to find out. And by finding the dou f by dou x and dou f by dou y, equate the values are is equal to 0, then after equating that is equal to 0, when we are solving that p and q is equal to 0, we get the values are called, that is the stationary values, or that is the turning values, or stationary points or turning points. That is the meaning of here. A point a comma b at which the dou f by dou x, the point is a comma b is equal to 0, the dou f by dou y at the point a comma b is equal to 0 is called, that is a stationary or turning points. The value of f of x comma y at the stationary point, that is a comma b, is called the stationary value. That means we need to remember to understand whatever the first order derivative with respect to x and y, equate the values is equal to 0, then solve the equations. By solving the values, we obtain the values. Therefore, that values are called, that is stationary or turning values. And again further, we need to remember what is the saddle point. The saddle point is nothing but whenever the function is having, there is no like maxima or no minima. That means neither the maxima nor that is a minima of the given function is said to be, that is a saddle point. That is the meaning of here. A stationary point a comma b is said to be a saddle point of the function f of x comma y if at a point a comma b is a given function has neither the maxima nor minima of the given function. That means that it is neither the maxima nor minima function is known as a saddle point. Based upon these are the 3 points we need to remember to understand, and after that we need to discuss how to find the maxima and minima values, what is the working rule of the given function under the 2 variables as well as the 3 variables, and what are the conditions to identification for the given function to finding the maxima or minima functions, that we need to discuss in the briefly. Here, the finding the procedure to find the extreme values. That extreme values is nothing but it is a maxima or minima values of the given function f of x comma y. And first of all, we need to assume the given function, that is f of x comma y. And after that, we need to find out what is the first order derivative with respect to x and y. That is the meaning of we need to find out the first point, it is dou f by dou x and also dou f by dou y. This is nothing but either the finding that p and also q, it is a small terminology. That is the first step to find out p comma q. And second one, by solving these two equations, that means after finding that p and q, we need to equate that 0, then you find the stationary points. And as we discuss in that clearly the definition of the stationary point. The stationary point is nothing but by solving that p comma q is equal to 0, we obtain the values are called that is a stationary values. And here stationary values we need to assume that a1 comma b1, a2 comma b2 and similarly so on. Because of depend upon the equations we obtain the different type of the stationary points, sometimes 2 points, sometimes 3 points, sometimes it is only the 4 points. That depend upon the equation of the order of the equation we obtain the different types of the stationary points. That is treated as a1 comma b1 up to so on. And further we need to find out what is the value of r comma s comma t. That as we discussed previously, that is a partial derivatives. We need to find out the r is nothing but the second order with respect to x, and s is nothing but dou square by dou x dou y, and t is nothing but dou square by dou y square. That means this is the we need to find out the second order partial derivatives with respect to x and y under based upon r comma s comma t, and sometimes it is also nothing but LMN is a terminology. And next further, we need to find out that whatever we obtain the stationary point, like already we obtain here, it is a1, b1 and again so on, that each and every stationary point we need to calculate at the point of r and again at the value of s and at the value of t. That means at the stationary point of a1 comma b1, we need to find out what is the r value, what is the s value, what is the t value. That means r comma s comma t is nothing but, as we know that is a second order partial derivatives. Whatever we obtain the second order partial derivative, we need to replace in that is a stationary point. And based upon this stationary point, that is r comma s comma t, further we need to identify what is the condition like that. That means we need to find out with the help of the rt minus s square. That means already in the fourth step, that is we know that what is the r comma s comma t at the stationary point. That at the stationary point r comma s comma t, after finding, again you need to find out what is the rt minus s square at the stationary point of one of the point. And based upon this one, we need to check the conditions. That is a conclusion of for the stationary point from the given stationary point according to based upon the following table. And the following table we need to observe properly. One is that what is the result of the rt minus s square, and again second one, what is the conclusion of based upon that rt minus s square. For example, it is a calculation the value of rt minus s square is greater than 0, and moreover it is r is also greater than 0. That means these are the two conditions are satisfied. That means one is rt minus s square is greater than 0, and as well as it is r is greater than 0 also satisfied. Then the function is said to be it is a minimum value. That means it is rt minus s square is greater than 0, and as well as r is also greater than 0, both the conditions are satisfied. The function is said to be it is a minimum value. For example, rt minus s square is greater than 0, but in case it is r is less than 0, then the function is said to be minimum value, that is a maximum value. And whereas in the first one, it is rt minus s square is greater than 0 and r is greater than 0, the function is the minimum value. But second one, it is rt minus s square is greater than 0 and r is less than 0, the function is said to be maximum value. But in case of it is rt minus s square is less than 0, that means wherever the function first one, second one condition is greater than 0, but in this third condition it is less than 0, it is satisfied, then the function is said to be it is neither the maxima nor minima. That means at the time of this one, the function is said to be saddle point. And further, it is rt minus s square is equal to 0, or it is r is equal to 0. That means the further investigation is required. That is nothing can be said about the maxima or minima. It is required the further investigation. That means according to this working rule of the maxima minima, first we need to follow that what is the p comma q, that is the first order, and solving that equations like p comma q, we obtain the stationary point. At that each and stationary point, you need to find out what is the r comma s comma t, and based upon that r comma s comma t, we need to find out the result and also conclusion based upon that. The condition is rt minus s square is greater than 0 and r is less than 0, the function is a maxima. But here it is rt minus s square is greater than 0 and r is greater than 0, the function is a minima. And it is rt minus s square is greater than 0 and r is less than 0, the function is a maxima. But rt minus s square is less than 0, the function is a saddle point. And rt minus s square is equal to 0, it is a further investigation is required. Based upon this result and conclusion, we can find out from the given any equations. According to based upon the working rule of, according to this the maxima and minima, whenever the functions are not constants, means without given the constants, we need to find out with the help of this the condition. Here same the and similarly if it is whatever we obtain that more number of stationary points like a1 a2 a2 b2 and a3 b3 like that, number of the different type of the stationary points are there. Similarly we need to follow that same the procedure. We need to find out each and every stationary points. We need to calculate what is the rt minus s square and again find that based upon that individually points what is the function is identified maxima or minima or saddle or something. Further investigation is required. We need to check that one by one at each and stationary point only. Now we'll go to discuss one example. Here find the extreme values of f of x comma y is equal to x cube plus 3xy square minus 15x square minus 15y square plus 72 x is the value. This is the, while we are going to observing this problem, the problem is based upon the function is under the two variables. That means the variables are here x comma y. Here we need to find out according to the working rule of the maxima and minima. Here what is the given function is assumed that f of x comma y, and after that we need to find out what is the p. The value of p is nothing but based upon that. In the previous sessions we discussed clearly how to find the partial derivatives under the first and second order, and based upon here also while we are going to finding that is dou by dou x, the function is obtained clearly 3x square plus 3y square minus 30x plus 72. And further we need to find out what is the dou by dou y. The dou by dou y is nothing but it is a 6xy, it is a minus 30y. That is according to with respect to y. And further we need to find out directly that is a r comma s comma t. Therefore here according to the second order, that is r is nothing but dou square by dou x square is nothing but the dou by dou x of the dou by dou x. That is the second order. And here the dou by dou x of the dou by dou x means already is completed here the first derivative. That value we can replace here. Clearly we obtain the dou square by dou x square is nothing but it is clearly the value is a 6x minus 30 is the value. And based upon according to in the previous sessions we discussed clearly how to find these are the first order and second order partial derivative. And based upon that we need to discuss here that same continuation to find the maxima and minima here. And similarly we need to find out what is the s. And s is nothing but dou square by dou x dou y. That means second order the dou by dou x of that is a dou by dou y. That means the dou by dou x of the dou by dou y. The dou by dou y is nothing but as we know that is a 6xy minus 30y is the value. And further we need to applying the dou by dou x of this one is nothing but it is a 6y is a that is a dou square by dou x dou y. And further we need to find out what is the last one, that is a t value. The t is nothing but dou square by that is a dou y square. That means the dou by dou y of the dou by dou y. That is the meaning of the dou by dou y of the dou by dou y is nothing but once again as we know that is d6xy minus 30y. That means that value we can replace here. We obtain the dou square by dou y square is nothing but it is the value is 6x minus 30 is the final solution. That means here clearly one part is completed to find the PQRST is the value. And further we need to find out what is a stationary point. And as we know that how to find the stationary point. And according to the first condition itself, it is completed all the values that is a PQRST. That means that is a first order and second order it is completed. And further we need to find out the stationary point. The stationary points are calculating by equating the P comma Q is equal to 0. Based upon that, by equating the P comma Q is equal to 0, here that P is nothing but as we know that this is the P equation, and Q, that Q is nothing but that also we obtain that here it is x square it is a, this is the only p only, and it is a q is nothing but 6xy minus 30y is equal to 0, and in that also we need to take out common, that is a 6y, therefore here x minus 5 is equal to 0. From this equation we obtain it is a y is equal to 0 and x is equal to 5 is a value. That means with the help of this is the y is equal to 0 and y is equal to that x is equal to 5, with the help of these two equations. That means with the help of this one and with the help of this one, we need to find out what is stationary point. While we are finding that stationary point with the help of these are the two equations, case 1 and case 2. Because of one is the case 1 along that y is equal to 0 and case 2 along that x is equal to 5. Therefore, according to case 1, if it is a y is equal to 0, we are going to replace in the first equation. We obtain that clearly that value is a x square plus here 0 minus 10x plus 24. That is a x is equal to clearly by solving according to the quadratic equation or any synthetic division. The values are x is equal to 4 comma, that is a 6 value. That means the conclusion of this one, the stationary point at case 1 that y is equal to 0, the values are here, one is a 4 comma 0 and 6 comma 0. Because of here, along this case 1, it is a case 1 y is equal to 0, the values are x is equal to 4 comma 6. That means one is a combination of 4 comma 0 and second combination is a 6 comma 0. These are the one of the like two stationary point, and similarly you need to calculate the case 2 also. That means according to here case 2 that x is equal to 5 along the first equation, that is equation is first is this one, and again we need to replace here x is equal to 5 also. After replacement of here x is equal to 5 based upon the case 2, we obtain the values are y is equal to plus or minus 1. That means y is equal to 1 comma minus 1 is the values. And while we are going to observing here that along the case 1, the first stationary points are 4 comma 0 and again the 6 comma 0. And similarly, here these are the 4 comma 0 and 6 comma 0. And case 2, that case 2 is equal to here, clearly showing that LH side, that is x is equal to 5, that is a case 2, that is x is equal to 5, that y is equal to 1 or minus 1. Along this one, the stationary points are, we obtain that clearly 5 comma 1 and 5 comma minus 1. These are the clearly two other stationary points. And finally, what we are observing here in this problem, here we are raising like that totally 4 stationary points. One is the 4 comma 0, second one is 6 comma 0, and the third one is 5 comma 1, and fourth one is a 5 comma minus 1. Based upon these are the 4 stationary points, we need to replace at r comma s comma t, and after replacing that 4 stationary points, again we need to further find out what is the RT minus S square, and based upon that we need to find the solutions. And again here, first of all, what is the result and conclusion like that? In the according to the working rule, clearly we shown that one is at a stationary point, and second one is what is the R function, and third one is what is S, and fourth one is a T, and what is the combination of like calculation of that RT minus S square, and again further what is the conclusion of the given problem. That means what is whether it may be maxima or minima like that any saddle point, we need to conclusion give the conclusion. Here the LH side the stationary points are, we obtain that 4 stationary points. One is along the 4 comma 0 and 6 comma 0 and 5 comma 1 and 5 comma minus 1. These are we clearly obtain the 4 stationary points. At this stationary point individually as per the working rule, we need to replace that 4 value at R value. That means in place of that 4 comma 0 in that R, that means 6 into 4 is that is a 24 minus 30. The value of R is nothing but it is clearly minus 6. And similarly, in place of S at y is equal to 0 is nothing but the value is nothing but that is a 0. That means S is equal to 0. And T, the T is nothing but 6x minus 30. But here that x is nothing but it is a 4. That is 6 into 4, that is also same like that minus 6 is the value. Now we need to find out what is the RT minus S square. That RT minus S square together, minus 6 RT minus means it is a minus 6 and minus 6 is a 36 and again minus 0. Therefore that is a 36 is the value. That 36 is according to the condition it is greater than 0, and based upon that the working rule of whenever RT minus S square is greater than 0, we need to observe whether it is R is less than 0, R is greater than 0. And here that R is less than 0. That means it is rt minus s square is greater than 0 and moreover r is less than 0. The function is said to be maxima function, maxima value. And similarly, at the point of 6 comma 0, again we need to replace here r function. Therefore, the r value is nothing but here also that is 36 because of x equal that is a 6, that is a 6 into 6 is a 36 minus 0, 30 is nothing but that is a 6 only. And here it is a s is nothing but y is equal to 0. Therefore, that s is also clearly the value is a 0. And further, we need to find out what is a t. That again we know that x is equal to 6, that is a 36 minus 30 is nothing but it is also same the 6 value. And now we need to observe here that rt minus s square is 6 into 6 is 36, and again that minus s square is the value is 0. That means 36 minus 0 is nothing but that is 36. Therefore, it is also greater than 0. And again we need to observe it is rt minus s square and moreover the value of r. But here in this case r is greater than 0. Therefore, according to the working rule, the procedure of this one rt minus s square is greater than 0 and moreover r is also greater than 0. The function is said to be minimum function. The function is said to be minimum function. And similarly, at the point of 5 comma 1, we need to replace in the r function. Therefore, the value is 0. And again, the s is nothing but it is a 6 after replacement of y is equal to 1. That value is a 6. And again, t at x equal that is a 5. Here also the value is a 0. And here, what we are observing here, rt minus s square. That means 0 into 0 is 0 minus 6 that is a square, that is a minus 36. That means minus 36 is nothing but it is a less than 0. Therefore, according to the working rule, it is rt minus s square is less than 0. And if it is rt minus s square is less than 0, as we know that according to the working rule of the procedure of this maximum minima, whenever the function is rt minus s square is less than 0, the function is said to be saddle point. The saddle point means, as we know that that is neither the maxima nor minima of the functions. And similarly, finally, the stationary point at 5 comma minus 1, it x is equal that is a 5 and y is equal that is minus 1, the value should be it is also 0 because of rt minus s square is nothing but 30 minus 30 is a 0. And again here, finally, it is also s is equal to 6y, that is nothing but minus 6 because of y is equal to minus 1 is the stationary point, it is the value is a minus 6. And t is equal to 6x minus 30, and it is also like that 30 minus 30 is something 0. And here rt minus s square is nothing but it is 0 into 0 minus 6. So that is also rt minus s square is nothing but it is also minus 36, and here also the condition is less than. Therefore, as per here also that schedule of the working rule here, it is also the function is said to be that is saddle point. That means neither the maxima or minima. That means based upon this one, the function is said to be it is one of the point is at the point is a maxima, but at the one point it is a function is a minima. But we require that find the maxima or minima of the given functions. Therefore, based upon that working rule here, we need to find the maximum value or minimum value, and whatever we obtained is a maxima at the point of 4 comma 0. That stationary point we need to replace in the given function, we obtain that maxima like value. And similarly, whatever it is a stationary point that is a minima, that value also we need to replace in the given function, we obtain the minima of the value of the given function. Therefore, here the maximum value at the 4 comma 0 of the given function. That means f of 4 comma 0, whatever the given function, like given function is like according to the quadratic equation is there, and in that we need to replace it x equal to 4 and y is equal to 0. That is the meaning of f of is the function in at x equal to 4 and y is equal to 0. After replacement of in the given function, we obtain the value is 112. Therefore, this 4 comma 0, based upon the conclusion of this one, it should be it is a maxima, it is a value. And again similarly, we need to find out what is a minimum value. And here, according to the condition, it is a minima at the point of 6 comma 0. Therefore, minimum value at the point of that is a 6 comma 0. That is a f of 6 comma 0 is nothing but same in the given function. We need to replace x equal to 6 and y is equal to 0. The value is clearly after that simplification, it is a 198. Therefore, these are the required to finding the maxima or minima from the given function after solving that stationary point, and again after that verification to condition with the help of the RT minus S square, we need to give that according to conclusion, and again finding the values of maxima and minima. And similarly, for example, other problem like here also find the extreme values of the given function. That means we need to find out what is a maxima or minima, that indirectly, and again the assume the function. We need to find out what is a fx and what is a fy, and again similarly what is a r comma s comma t. That means these are the first order, it is a p, and again q, and again it is r, and again it is a s, and again it is also, and again further it is a t is a value, and that is based upon the first order and second order partial derivative with respect to x and y. And this is the first step is completed, that is indirectly finding that PQRST one task is completed. And further we need to find out what is the stationary points. The stationary points are calculated with the help of, that is by solving that p comma q is equal to 0. Here by solving that p comma q is equal to 0, we obtain that clearly these are the p is equal to 0 and q is equal to 0. For example, first and second equation by solving, here also we obtain that these are the 4 steps, like 4 stationary points. And similarly further these are the 4 stationary points we need to calculate, like at the presence of r comma s comma t, and based upon that at the point of 0 comma 0 the value of rt minus s square is greater than 0, and it is also r is less than 0. That means greater than 0 and r is less than 0 is nothing but the function is said to be, it is a maximum function. And similarly the second point, that is r is equal, that is at stationary point 2 comma 0 at the given function rt minus s square is the greater than 0, and here also r is greater than 0. While we are going to observe here, it is greater than 0 is nothing but it is maximum value, but it is a greater than 0 and it is also greater than 0, it is nothing but it is a minimum value. Means it is both are the greater than 0, the function is said to be minimum value. And again further we need to find out 1 comma 1 and minus 1 comma minus 1, and based upon the stationary points, while we are going to calculate, that is rt minus s square is less than 0. That means the first step itself, it is a less than 0 is nothing but the case is not possible to find the maxima or minima. The further investigation, it is a required value. That means we need to find out that is not possible to find, that there is no extreme values of the given functions. And now as per the same previous year, wherever it is a maxima and a minima, that particular these 2 points we need to find out what is a maxima or minima value particularly from the given function. Therefore based upon here, according to the result and example conclusion, we need to find the solution. And similarly find the extreme values of x cube into y square into 1 minus x minus y, and again we need to simplify after that multiplication. This one we obtain clearly like this. And further based upon that, again the same working rule of that maxima or minima, we need to find out what is the PQRST. Here one is a p is a value of this one by using the partial derivative with respect to x, and similarly with respect to y is also nothing but it is treated as, and again similarly after that the r value, and it is after that derivative with respect to you obtain like this. And again s is also the dou square f by dou x dou y, that is dou by dou x of the dou f by dou y is nothing but, as we know, the dou by dou y, that value we can replace here. We obtain that clearly, that is 6x square y minus 8x cube y minus 9x square y square is a value. This is the s value. And further we need to find out what is the t value also. Therefore that is nothing but the second order dou square f by dou y square. Therefore dou by dou y of the dou f by dou y is equal to, as we know the dou f by dou y, that value we can replace here, and again we need to replace. Finding the solution, we obtain clearly it is a t value. And it is the first target itself completed, and further we need to find out what is the second order, and again the according to the stationary point, what is it? According to stationary points are calculated by equating that p comma q is equal to 0. That means solving the p comma q is equal to 0, we obtain that clearly. This is the first equation, we equate the 0, and second equation we equate the 0. And by solving here the first and second equation together, we need to find the x comma y. I think by solving these are the x comma y, we obtain that 1 by 2 comma 1 by 3. I think maybe it is stationary points 1 by 2 comma, that is a 1 by 3, that y is equal to 1 by 3, as we know that directly by solving that solving the system of equations. And these are the two stationary points. We need to replace at r comma s comma t, that is at r is equal to minus 1 by 9, and again that s is equal to minus 1 by 12, and t is equal, that is minus 1 by 8. With the help of these are the two stationary points, that is x equal to 1 by 2 comma 1 by 3 in the r comma s comma t. That r comma s comma t also we already completed in the previous slide. Here what is the value, and again further we need to find out what is the rt minus s square. Therefore the calculation of rt minus s square is like that, and again after that simplification clearly it is a 1 by 144. That 1 by 144 is nothing but it is always it is a it is a greater than 0, because of it is a positive value. That positive values is nothing but any values of the positive values is nothing but it is a greater than 0. Therefore the conclusion it is rt minus s square is greater than 0. And again here moreover it is rt minus s square is greater than 0, and again here r is equal to, that is a less than 0, because of the negative is nothing but it is a less than 0. Therefore it is a conclusion of it is rt minus s square is greater than 0 and r is less than 0. As you know that the working rule, the function is said to be it is a maximum function. Therefore the function is said to be maximum function at the point of 1 by 2 comma 1 by 3. But we need to find out the maximum value of the given function at the point of 1 by 2 comma 1 by 3. Therefore this 1 by 2 comma 1 by 3 we can replace in the given function. Therefore the maximum value of the function at 1 by 2 comma 1 by 3 after replacement of in the function, that is at x equal to 1 by 2 and 1 by 3, and again the total simplification we obtain 1 by 432 is a final, we require the maximum value of the given function. And similarly we can find out any problems are given according to, for example, find three positive numbers whose sum is 100 and whose product is a maximum. That means, but in this problem it is not given the directly the problem, it is given that something statement wise. First we need to understand the find the positive, that is a three positive numbers. That means, for example, you need to assume that x comma y is a z is a three positive numbers, and based upon that it is a sum is given the 100. That means x plus y plus z is equal, that is a 100, and whose product is a maximum. That means product is nothing but it is finding the x y z. Therefore f of x comma y comma z is nothing but x y z is finding the value. And here whatever that x y z is required to find out, that z values, as you know that from the sum we need to find out that z is equal to, that we can replace here, that is a condition in presence of z is 100 minus x minus y. Therefore this is the required, the given required function, and based upon that again we need to further the previous concept, we need to find out what is a p comma q comma r comma s comma t. Therefore while we are finding the p, that is a p is nothing but that is 100y minus 2x y, and again minus y square, that is a p is equal to 0. And again similarly this is nothing but p after derivating with respect to x, and similarly derivating with respect to y also as a partially, the value is nothing but obtained according to this is the equation of clearly we obtain that. By solving these are the 1 comma 2 we get the stationary points. As we know that the stationary points are calculated with the help of the p comma q is equal to 0 solving. Therefore clearly by solving the first and two equations we get the values are, it is x equal to 100 by 3 and y is equal to 100 by 3. And further again we need to replace these are the stationary points in the function of r comma s comma d. That therefore as we know that r is a function is after that simplification it is minus 200 by 3, and s is also, that is after the replacement of 1 by 1 finding the derivative we obtain like that. And here rt minus s square is the conclusion of this one, it is a greater than 0 based upon that after the simplification, and here rt minus s square is greater than 0, and again r is a less than 0. As we know that again the condition is it is a maximum function, and we need to find out the maximum value. Here x is equal to 100 by 3 and y is equal to 100 by 3. Therefore that z is also nothing but the required value in that replace, it is a solution is 100 by 3. Therefore it is a clearly the required values they are asking to find out. The maximum means that is 100 by 3, 100 by 3, 100 by 3, that together the values is nothing but 100 whole cube by, that is a 27 is a final required solutions. For example, it is also somewhat different type of the problem under the trigonometric functions. Here find the extreme values, that means you find out that maximum or minimum of the function under that sin x into the product is a sin y into sin of x plus y, provided the plane triangle is nothing but 0 is less than x is less than y is less than 100, pi is a value. That means lies in between 0 comma pi is a x comma y is a rotating. Here also that p and also q by using the multiple and component angle formulas, we need to find the solutions. By take out common, when we are derivative with respect to x, treat y as a constant. When derivative with respect to y, treat x is a constant. By solving according to like this, p comma q comma r comma s comma t, that is the first and second order, we need to calculate. And again here also, after finding that p, q, r, s, t, we need to find out the stationary points are equating by equating p comma q is equal to 0, nothing but p is equal to 0 and also q is equal to 0 is the value. That is indirectly the terminology. That first is the p is equal to 0 and q is equal to 0 is nothing but like this. By solving these two equations, for always it is under the trigonometry functions, any products and again the additions are given. By solving that p comma q is equal to 0, we obtain that finally x is equal to pi by 3 comma pi by x is equal to pi by 3 and y is equal to pi by 3. These are very important to understanding. By solving the trigonometric functions, sin x into sin y into sin of x plus y, or sin x plus sin y plus sin of x plus y, and cos a cos b cos c and cos a plus cos b cos c, like that. Any type of the trigonometric function lies in between the limits are under 0 comma pi. By solving that, we obtain that most other points are also we obtain, but we need to consider these are the two stationary points are important to our consideration. That is pi by 3 comma pi by 3 is a value. And this pi by 3 comma pi by 3 we need to replace in that r comma s comma t, whatever we obtained that previously r comma s comma t. Therefore, with the help of the r minus s square, the value is clearly it is a greater than 0, and moreover it is also r is a less than 0. Therefore, the function is a maximum function at the particularly pi by 3 comma pi by 3. Therefore, maximum value means we need to replace this particular point in the given function. We obtain that clearly, that is a 3 into root 3 by 8 is a value. That means x is equal to pi by 3 and y is equal to pi by 3 value. Like this is also some related the rectangular box open that up. We need to understand what is the volume of this one, and again what is the surface of the problem. The surface of the problem is nothing but actually the 2xy plus 2yz plus 2zx, but in the problem is given one side it is open at the top. Therefore, one side I remove that 2xy is equal, that is 1xy. Therefore, consider based upon xy plus 2yz plus 2zx is the value. And again here based upon the PQRST, after simplification this one we obtain that x comma y. Here these are the solutions. The stationary points are by solving that x comma y is equal to 6. After the simplification like the solving the stationary points, we obtain that clearly r comma is equal to, that is r is equal to 2 comma 1 comma, that is a 2. And here rt minus square is nothing but it is a greater than 0, but it is also r is greater than 0. The function is itself to be, it is a minimum value. Because of rt minus square is greater than 0 and also r is greater than 0, the function is a minimum value. But we need to require the minimum value at the point of the given function. Therefore, x is equal to y and again y is equal to 6. Therefore, z is equal to 3 is the final solutions. And next further we need to discuss the Lagrange's multipliers. And actually the Lagrange's multiplier method is also under the maximum minima whenever the function is connected with the another functions. That means what we are observing the previous problems are based upon directly calculated with the help of the PQRST. But here by using the Lagrange's multipliers, that means whenever the function is connected with the another function, that is by using that Lagrange's multipliers method. And at the time of that, the connected function is assumed that there is a lambda f plus capital F is nothing but we assume that f plus lambda into pi is the value, and based upon that condition we need to find the solutions. And this is a drawback of this is the method is no information about the nature directly the point of the condition. This is the very important to understand. And while we are going to discuss, these are the some important points to remember. What is the constructed, the new function, that is a capital F is nothing but small f plus lambda into pi, and f is nothing but to finding the equations not given the value, and pi is nothing but connected with the given value, and based upon that we need to find out directly the by x. These are the two functions. For example, discuss one problem based upon this one. Find the maximum and minimum values of these functions, and here by using the Lagrange's multipliers. While we are going to observe in this one, clearly mention that finding that by using the Lagrange's multipliers, that means we need to understand what is the identification, what is a f and also that is a small f and what is a pi. And here we need to assume that there is a capital F is nothing but small f plus lambda into pi. And again, f is nothing but in the two functions, one is the x square plus y square plus z square, and in this x plus y plus z is equal, that is 3a. While we are going to observing these two conditions, whatever the not given the value, that means it is x square plus y square plus z square is not given, that is assumed that f. And given the function is the subject to the condition is given, that is the meaning of pi is a condition. That means we need to assume that pi is nothing but x plus y plus z minus 3a is the conditions, is equal to 0. And based upon this one, we need to require the constructor of the new function, that is a capital F is equal to small f plus, that is a lambda pi. Therefore, f whatever we know that addition of this one and again plus lambda into pi, that also we need to replace here, that is a pi value. And similarly, based upon this one, we need to find out what is a dou a by dou x is equal to 0, dou a by dou y is equal to 0, dou a by dou z is equal to 0, along with the given functions condition, that is a pi is equal to 0. We need to find out x comma y comma z after eliminating lambda value. Here, first of all, from the equation that is pi, we need to find out what is fx, the value of fx, and here from this lambda minus 2x, and here fy is equal to 0, that is 2y plus lambda, and here also from this lambda is equal to minus 2y, and again further that fz, that is also 2z plus lambda, therefore lambda is equal to minus 2z. And these are the three equations. Together, the fourth equation is nothing but whatever the given condition equation. That means that is the given fourth equation is x plus y plus z minus 3a is equal to 0. And this is the fourth equations. And by using these are the four equations together, first we need to eliminate lambda, and again by using the fourth equation, find out x comma y comma z. While we are going to observing first, second, third, here comparison to first and second, for example, why? Because that first and second and third, all the equations are it equate the lambda, here equate the total three equations. Therefore, comparison here first and second, that is a 2x is equal to y, the value of here x is equal to y. And similarly, comparison in between the second and third, and y is equal to 0. Therefore, here x is equal to y and y is equal to z. That means with the help of these two equations, we need to replace using the fourth equation, we find the x comma y comma z. That means whatever we obtain, that is the fourth equation, in that we need to either reduce into x or something y or z. We need to find out what is the values of x comma y comma z is the values. Therefore, by replacement of along with the fourth equation, we obtain clearly x is equal to a, y is equal to a, and z is equal to a. Therefore, that values we can replace in the, they are asking to find out, that is a x square plus y square plus z square is a minimum value. Therefore, a square plus a square plus a square, whatever we know that x, y, z, therefore the solution it is a 3a square is a minimum value of the given functions. And similarly, any problems are given, we need to use by using that is a clear procedure to find the maximum or minimum values under the Lagrange's multipliers method. Same, it is also known values we need to understand, and what is a non-condition, not condition is given, that is also considered. Not condition is given that is treated as a finding the value is f, and again the condition subject to the condition is given that pi is a value. It is a f value and it is also pi value. And based upon that, we need to find out dou by x. First equation itself, fx is a 1 plus, and from this lambda is equal to, and similarly fy, and here also lambda is equal to, and similarly that fz, here also lambda is equal to z square, and these are the three equations. And fourth equation is a subject condition is given, that is 1 by x plus 1 by y plus 1 by z is equal to 1. And along first we need to equate the first and second and third, eliminate the lambda, that is x square is equal to y square is equal to z square. And with the help of the 3 together with the help of the 4, we need to find the x, y, z. Here by equating first and second, and after that finding that second and third, then you obtain the y is equal to. By using all these values x, y, z interrelations, we need to, with the help of the fourth equation, find the value. Therefore, by using these are the x comma y comma z, we need to replace in that whatever they are asking to find out. There is a maximum and minimum values of that. That means here plus or minus 3, plus or minus 3, plus or minus 3 is nothing but one thing, it is a plus 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 is nothing but you obtain that clearly, it is a plus 6. And again other thing, it is a minus 3 minus 3 minus 3 is nothing but it is a minus 9. By comparison in between this one, plus 9 is a maxima or minus 9 is a minimum value of the given functions. Something like that, any problem is given like that, we need to understand to finding the maxima or minima of the given functions, it is based upon either under the constants and also under without any constants. That is by using the PQRST procedure or something by using any the condition of the capital F is equal to F plus lambda into pi, that is a Lagrange's multipliers method. Yeah, we need to find the solutions. Like this, number of problems and number of solutions are also available. That depend upon our simplification, depend upon the calculus, we obtain the different type of the solutions. Some many number of problems are available here. We need to focus on that. Like such type of, these are the under the rectangular parallelepiped. The rectangular parallelepiped of the value is nothing but it is a 2x 2 by 2z, that is 8x by z, means it is not given any value. That means we need to assume it is a small f. And subject to the condition is given, this is the given value is nothing but it is a capital F, that is a pi. And with the help of this one, that is a capital F is nothing but small f plus that is a lambda into pi. Therefore, with the help of this one, we can replace, and further we need to find out what is the fx, fy and fz. And again here also same like that, to equate the first and second and third, we eliminate the lambda value. And again that after eliminating lambda, we need to replace in the condition, then we with the help of the condition value, then find the value of xyz. And based upon that xyz, again as we know that how to find the solutions after replacement of in the required solution, here it is a xyz, that is 8xyz, and this xyz we can replace in the 8xyz. That means that is 8abc, that is a 3 root 3. If it is a greatest is asking, that means maximum is nothing but plus 8abc by 3 root 3. It is the lowest means that is a minus 3 8abc by 3 root 3 is the solution. Same it is also like previously one of the problem is completed. We can find the solutions like according to any problems are given based upon this is the clear working rule to find the maxima or minima problems by using the PQRST and also that is the Lagrange's multipliers method. Like that. Clearly showing that eliminating 1, 2, 3, that is a lambda value, and again together the fourth equations. Yeah, these are clear equations. Like this is also some point is given, then how to find the solution based upon that clearly that distance between the 2 points based upon the concept we need to find the solutions. Yeah, here to find the solutions. Like the last problem, this one to find that. Actually, it is origin is nothing but given the points is one is x comma y comma z, and again northern point is something 0 comma 0 comma 0. While we are going to finding the roots in between, that is x minus 0 whole square plus y minus 0 whole square plus z minus 0 whole square. And again here that is a PQ value. When you are squaring, PQ square is nothing but square eliminated. X square plus y square plus z square is the equation. This value can be applied. Consider this is f is a function, not given the functions. That value we can replace. Yeah, similarly like that. Procedure of that under the. If you understand properly, then easy to get the solutions. Nothing to worry. X is equal to 0, when lambda is equal to z is equal to plus or minus 1. That means one of the values 0, 0, 1 and 0, 0, minus 1 is the solutions. It is required the points. And like that, any problems are given, we need to find out this one. I hope everybody understood according to under this is the maxima and the minima under the 2 variables and 3 variables. The given like x comma y and again x comma y comma z by using the PQRST method, that is without constant, and with constant is nothing but by using the under the Lagrange's multipliers method. If any problems or something, any suggestions, please give me the reply to this link only. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.